Okay, so we're going to go quickly through scale factor. And this goes back to the unit that we just did on ratios and proportions. So scale factor is the ratio of the side length of one figure to the length of the other figure. So like I used in class and we've used before, the floor plan versus the actual building. Okay, so it is also thought as the common multiple. And where I come in here, I can see this as if I have 2/3, it's equal to 4/6 because I multiplied it by 2. Okay, so this is consistent. So this is my scale factor of 2 to 1. Okay, so my scale factor is that ratio that is happening between the original and the new. Okay, so using or trying to find scale factor, I can look at figures like this. Okay, so I am looking at this figure here, and it says 3 to 8 and 6 to 18. So these are the side lengths. Well, they are similar, and similar means same shape and not same size. Okay, but we have corresponding sides. Okay, so this side corresponds to this side, and this side corresponds to this side. So we apply 3 to 6 and 8 to 16. Okay, so these are separate. These are not, I'm not doing these as proportions, but so let's see, 3 to 6. If I reduced that, that would be 1 to 3, or 1 to 2, I'm sorry. So then if I reduce my 8 to 16, because I'm comparing these, I would have a 1 to 2. So my scale factor ratio is 1 to 2. Okay, so over here, 10, well, this one doesn't work because this is a square and this is a rectangle. So let's look here. Okay, so let's compare 4 to 8, 3 to 6, 3 to 6. Automatically, I can look and see 4 to 8 is 2, 3 to 6 is 2, and 3 to 6 is 2. So my scale factor is 2. Okay, so this has gotten larger. One thing to note, scale factors greater than 1 enlarge a figure. And we'll talk more about that in a couple units. And less than 1 but greater than 0 reduce. You do not have a negative scale factor. Scale factor. Okay, you do not have a negative scale factor. Okay, it's between 0 and 1 or greater than 1. All right, so then let's look here. And I'm trying to find a good one to do. All right, so let's look at this one. We don't have anything to correspond to that 8, but we do have a corresponding between the 21 and the 14. So we can figure this 21 over 14. We can reduce this. A common factor between these is 7. 7, 14, 21, that's 3. 7, 14, that's 2. My scale factor ratio is 3 to 2. Okay? So I noticed on the very beginning I called out that I said AKA the common multiple, and it's not the common multiple, it's the factor. It's what we multiply both of them by to get the same value. Okay, so one other example I want to show is using the scale factor. Okay, so using the scale factor. This says the scale has a map of 5 feet to 20.5 miles. If the actual is 15.5, okay, what is the map? Okay, so I have to follow, these are proportions. I have to follow the same pattern. So I'm going to do map over actual equals map over actual. Okay, so the map is 5, and I'm not worrying about I'm going to go ahead and label my units, but they aren't necessarily important at this point. So I have 5 feet over 20.5 miles, okay, and then I have X feet over 15.5 miles, okay. So when I go and I figure out what my calculation is, I multiply 15.5 times 5. That gives me 77.5 equals 20.5x. Okay, so then I would divide by 20.5. And I get 3.78. That was not a pretty answer. Okay, so I get 3.78 feet approximately for 15.5 miles. Let's look at this one. This one might be a little prettier. Okay, so this is up with this problem. Okay, so now this one, a scale map is 7 meters to 14 miles. So if I have 14 miles, or 14 meters, how many miles do I have? So I'd set it up, miles, or meters to miles equals meters to miles. So 7 over 14 equals 14 over x. Okay? 14 meters, 7 meters, 14 miles, x miles. So I cross multiply 14 times 14. That gives me 196 equals 7x. Divide by 7, divide by 7. 196 divided by 7 equals 28 miles. So x equals 28. So this is using the proportion and that scale factor ratio to find missing sides or missing information. The other is finding the scale factor given the information. So this is where I was, given the different sides, and I had to find the scale factor. So what you are going to be asked to do is you are going to be asked to enlarge and reduce a drawing. Okay, so you guys do this a lot in art class. Okay, we do this a lot in STEM. So we need to create a scale drawing. So we are going to take our actual and we are going to make it into our drawing. Okay, so our actual for our water tower will be, I believe it's 2 inches for every 1 block on the grid paper. Okay, so 2 inches, and that's actually about 1 centimeter. 1 centimeter. So 2 inches to 1 centimeter. Okay, so then if I were looking and I was creating my tower, and I said my tower is 24 inches tall, and I want to know how many centimeters do I need to draw it, I compare it to my scale factor. 2 inches, 1 centimeter. So I suggest do your calculations first. Okay, do your calculations first, because then you can always go draw it based on what you've already done. But if you wait and try and do them as you're doing it, you're going to have to erase a lot for your drawing. All right, so this is 24 equals 2x divided by 2. So it's going to be 12 centimeters. Okay, so your 24-inch tall water tower will be drawn at 12 centimeters. Okay, and it must be the same scale for every single part of the water tower. So you're going to be working on an assignment where you are taking a house and you are going to enlarge it and reduce it. Okay, so that's where you're going to practice your changing in your scale drawing, as well as practice finding the scale factor and using the scale factor to find missing sides.